Righty. Session number 15, ANZ Coders 2015, presented to you by Man Without Voice and Rob Moore. We are in here for the final session. I don't have my young offspring here to do this particular intro. She's decided to do something more interesting, like lick the windows or something. So we have for this session, to bring it home, Rob Moore going to be talking about TestStack.Dossier. I'm going to continue to slowly die over here in the corner, as you can hear. I really appreciate you guys who have stuck with us throughout the entire week for this conference. It's been fantastic. I've really enjoyed it from this end of the pipe. So hopefully you've been enjoying it from the other end. And Rob, I'm going to hand it straight over to you. You can do your magic and regale us with your awesomeness.
Excellent. Thought I'd just show you my face. Hello, everyone. Today I'm going to be talking to you about some useful testing patterns. I'm also going to be talking a little bit about a library that I've created called TestStack.Dossier. In particular, the patterns I'm going to be covering are around test data generation, because it's an area that I find is lacking in a lot of projects. So today I'm going to be talking about what makes a good test. And if you can, it'd be great if you can start sounding off in the comments about properties that you think make up a good test, because we'll have a little question in a minute, and that helps me with the 20-second lag. I'm also going to talk about why it's difficult to kind of keep those properties alive as our projects grow in complexity and size. We'll take a little bit of a look at TestStack.Dossier, and then we're going to look at how we can create objects and how we can create values, some of the patterns around that, and also some code samples for that. So hopefully you heard my question, and you can start standing off in the chat around what things you think make up a good test. And hopefully you are not silent. Oh, this could get awkward. Single concern, nice. That's a good one. I'm just going to wait for like another 10 seconds and we'll see what comes up. We need some elevator music. Clear names. Richard's winning the prizes here, I think. Everyone else is just really silent. All right, I'm going to carry on.
No, it's because I've got the advantage. Actually, I can give us, let's see what I can do for some background music using cheesy effects.
I've just given half of the game away anyway. Nice.
No, maybe not that one. Maybe not.
Oh, there we go. Reliable. Tests that fail occasionally are valueless. That's really good. I like that one. Tag. Cool. All right, I'm just going to dive in. So here are some of the ones that I think fast feedback is really good. Small feedback loops are awesome. Obviously, confidence, that's what tests are really all about giving us confidence. I think tests that are focused are really good. You know, if they wander and they're trying to test multiple things, it's confusing. Tests that are repeatable. So we've already had the one about reliable. It's the same sort of thing. There's a couple more here that I'm mostly going to focus on in this talk. So I think that tests need to be maintainable. And I firmly believe in that kind of notion around tests acting as documentation for your system. So those two are the ones I'm mostly going to focus on in this talk. To my mind, if you want your tests to be maintainable and to act as documentation, then they need to be readable and they need to be understandable. And I think that for them to be readable and to be understandable, that they need to be consistent and they need to be clear in intent. So a lot of the patterns that I'm going to be talking about, their kind of goal is to help with consistency and clarity of intent, with the aim of helping with maintainability and tests acting as documentation. Now, I've seen a fair amount of code bases as a consultant, and certainly what I've noticed is that when projects get bigger, there's a tendency to have like pretty awful test projects. They kind of end up being pretty bad. They end up being pretty tedious to add new tests and to edit the existing ones. They tend to be quite complex to understand. They tend to be thus hard to maintain. And there tends to be a lot of repetition in there as well. So, you know, it makes it hard to sort of refactor, because, you know, you've got the same kind of code everywhere. And in particular, if there's any kind of bugs in your test code, then, you know, they get propagated everywhere. And it's not a very nice situation to be in. So what I'm trying to say is we seem to inadvertently end up throwing goals that we just talked about, maintainability, consistency, and clarity of intent, out the window, which makes me sad, which is why we've got a little sad face there. So the next question, I don't know if I want to wait the 20 seconds because that's really awkward, is why do we do this to ourselves? So I'm just going to dive right in. I think it's because we're not treating our test code like our production code. So to my mind, to try to combat this, what we should be doing is refactoring our test code bases mercilessly, like we do for our production code bases. We should be applying useful patterns, like some of the ones I'll be covering today. We should be continuously improving our tests, and we should be thinking about testing rather than just kind of, leaving it aside as just that thing that we do. I had a testing talk earlier in the week at the Yale West conference, and one of the people came up to me afterwards and said, "Oh, I don't generally bother going to talks about testing because I think they're boring." Nice of him to say to me as well that he actually found that one quite interesting, which is cool. Now, the other thing is that we shouldn't just take tests for granted. We should love our tests. There is one aside that I will say on this slide, which is that our goal isn't to write tests. Our goal is to ship value. So you should only be writing tests if you need them for confidence. If you don't need that, don't bother. But if you are writing tests because you do need the confidence, then you should be doing this stuff so that your tests don't end up slowing you down later on down the track. So this is about keeping our tests, let's say, agile, throwing the buzzwords. So we'll take a quick aside. I've created a library called TestStack.Dossier. Essentially what it's about is leveraging some of the patterns I'm about to talk to you about so that you can more easily and quickly generate data that's terse, readable, and maintainable. So it helps with the goals that we were talking about just before. So let's start by looking at what we can do in terms of creating objects, because most tests seem to require us to do this that I tend to be writing. So we're going to be using a code base that I've written in GitHub. And what I'm going to do is I'm going to, hang on. No, that's not what I wanted. I want that one. I'm just going to paste a URL into the chat for everyone. And there. So if you want to follow along, feel free. Otherwise, you can just look at the code as I've got it. So here we go. We don't want to see that yet. That's a spoiler. So what I've done here is I've basically created something that will look like a little bit of a domain model. So domain-driven design type entities. And what we've got is the root one's probably a product. And a product basically just has a name. It's pretty boring. But what it does also, oh, hello, that scrolls a lot. What it also does is it has a list of campaigns. Now, a campaign, if we go into that, has a demographic and a start and an end date. So the start and end date tell you whether or not the campaign is currently active, and the demographic gives you a state, which is just one of the Australian states, or a minimum age or a maximum age, which allows us to target a member. And a member's in here, and a member just has a name, a state, and a date of birth. So, the problem that we have with these patterns is that, in demonstrating them, I should say, is that they really come into their own as your domain gets a lot more complex. So it's hard to find the right balance with something that's very simple to understand, but actually demonstrates some of the value in these patterns versus something that's really complex and hard to understand, but really demonstrates the value. So hopefully this is easy enough for you guys to understand, and it strikes a nice balance, I guess. So I'm just going to show you some tests that I wrote with no patterns at all. So we've done some tests against the demographic that demonstrate the contains method, which takes a member and now and tells you whether or not that member is actually covered by that demographic. So we've got one here. It's for all members, when checking if the demographic applies, then return true. We've got some other data-driven ones here. It's given a demographic for any age in specific state, when checking if the demographic applies, then something, return true only if the member's in that state. So just some examples of tests that you might write. And we're newing up all the objects here directly. We've got lots of values in here, and we'll start talking about some of the problems in these tests. There's one more example that we have, just so that we can generate lists of information, because that's quite an interesting thing to do. We've just got an example of some sort of query, get products for member. It takes an iQueryable of product, and it will return us all of the products that, so where there's a campaign that's currently active and where the demographic contains a member that was passed into that query. And we've got a corresponding test, get products for member tests, that there's two of them. It's just, given there's no products when querying, there's no results. That's pretty obvious. There's more than two, there's three. Given products with no campaign or a campaign that isn't current when querying, return no results. And then, some where they do and don't apply. So these are the tests that we're going to be refactoring using patterns. As I said, the code base is on GitHub, so I'm just going to look at little parts of it, but it'll make more sense if you look at it after the fact. So just to rehash, our goals here are to get consistency, clarity of intent, and maintainability with our tests. So first pattern, some of you may have heard of it. Feel free to sound off if you have or haven't, is the ObjectMother pattern. So what this might look like is something like this. We're going to use demographic for most of these examples, just so that we keep a consistent object. A consistent concern that we're looking at. So the ObjectMother pattern is basically a static class nested inside the ObjectMother class that then has some properties or methods that return some sort of pre-canned object. So in this case, you might have the all members demographic, or you might have one with a state and an age range, somewhere from WA between 18 and 19. Or in this case, we've got some methods where we're passing values in, which we're using for the data-driven tests. This is basically the ObjectMother pattern, except the other part of it, of course, is that there is, other nested classes in the ObjectMother for the different types of objects that you might be building. So if we have a look at the tests that we've refactored using ObjectMother, this is what they now look like. There's actually a lot less noise in there, which is quite nice. So in this case, ObjectMother, members.thread, and then we've got demographics.allMembers. That's quite nice. We've got some here that allow us to choose one that has a specific set date. One of the really nice things about the ObjectMother is the IntelliSense that you get. So add some discoverability to the objects that you're building, because you can just go .off ObjectMother and then you see all of the different options. So some of the advantages of the ObjectMother pattern, we've got reduced constructor calls. So one of the problems in the existing code base is that if you've got constructor calls for all of your objects in all of your test cases, you can imagine that for an object like, say, member, that's a core object of our domain, maybe you might have 50 or 60 instantiations across your code base. And what that means is 60 constructor calls. So the moment that you want to refactor your member to add in a new property, maybe email address in this case, you've now got to go to 60 instances of that and start adding in random values. Or, worse, you might pollute your domain, put in like a default value for it or something nasty like that. So the cool thing about the ObjectMother pattern is if we have a look at it, then, now we've only got, say, 5. So it's a little bit easier to refactor. Our important values are named. So if we compare this test, let's say up here, all members. No, actually, that's not a good one. Let's say this one here. So we're talking about like a minimum age. If we compare that to the one that we had before, where we've got the minimum age, we're passing in these like null values here, or like here we're passing in name and WA and stuff like that. Those values don't matter for that test. They're actually noise, and they make it hard to read that test and understand which values are the important ones. So we've actually, by using the ObjectMother, we're naming the important values in the name of the property in the ObjectMother itself. We're also getting a lot of consistency, and that's from that ObjectMother dot that I talked about. Every time you want to get an object, all you need to know is you go ObjectMother dot, and then you use IntelliSense to get the rest of the way. So some disadvantages though. There's still a lot of constructor calls, particularly for something like, say, a member where you're going to use it a lot. So there's probably going to be a lot of variations. So you're probably going to end up with a lot of different properties on the object mother. And that's where the object mother turns into a God object. It becomes very complex, and that's pretty nasty to deal with. And it's hard to see at a glance what's in the object mother because you're scrolling for days. You also tend to get really long names because you've kind of got to describe that, it's a member from WA who's 18 and has pink polka dots on their shirt. And, those names start getting pretty crazy. And it's also a little bit more tricky to do data-driven tests. You can kind of do some of the stuff like I had there with the methods, but, when you're passing in multiple values, it just starts getting a little tricky. So at the point that most people realize that the object mother pattern has limitations, they tend to turn to the TestDataBuilder pattern. What this looks like, no, don't save it, is, drum roll. Actually, no, we're going to start with this one. Something like this. So this is a classic implementation of the TestDataBuilder pattern for the demographic. You have some fields that store all of the values that you need to pass into the constructor. You have a build method that returns the demographic and passes those values in. And then you have other methods to kind of mutate those fields that you're storing the values in. And then in the end, what it looks like in the test is something like, let's choose a more interesting one, this one here. Like this. So you've got new member builder, in state, state, new demographic builder for state, state, and you build them. There's quite a bit more noise in this, like with these constructor calls. There's just something interesting to point out. Now, it's at this point I might take a quick aside and look at some of the features that you get in TestStack.Dossier. So first thing you do is you inherit TestDataBuilder. And you put in the type that you're building, and then you put the type of your builder. And it's a little bit weird in that it's a recursive type definition, but that's just needed for some of the base types to return the correct builder type for the fluent stuff. So one of the things that gets really annoying about creating these builders is that as the object you're building becomes more complex, you could have, say, 10, 20 properties up here. And it just becomes A, hard to read it, and B, kind of a pain when you're trying to create these things because you have to create all these fields and all that kind of stuff, even if you do have ReSharper. So what we can actually do is we can start to get rid of these properties. And what we can do instead is we can use something called set, which is on the base class. Now, what set allows you to do is to reference public properties from the object you're building, because most of the time, the values that you're holding correspond one-to-one with properties that you're exposing on your object. And then we can sort of start putting in values in there. Now, that one's kind of boring, but this one's a little bit more interesting. So we can just say state, and then we can pass in the state. That's nice. And we can do that for all the other ones as well. But there's still like a bit of noise here. We can remove that and just return that. So even nicer. If we then went and changed minimum and maximum age to use set as well, actually no, before we do that. So there's a corresponding get that allows you to pull the value back out again. There's not too much that's happening here. It's essentially turning that into a string and storing it into a dictionary of objects in the base class. So there's not too much magic going on. But if we then changed minimum and maximum age to use set as well, we could actually just get rid of that method altogether. And then you'd basically be left with the example that I have, the final example, which is here. So we can see it's just a lot terser, which is nice because it means that it's very quick to create these. The other thing is that, pro tip, I guess, would be only create these methods when you actually need them for a test. So to start off with, you might need one or two, and then over time, as you add a test that needs some other behavior to configure, then you can add the other method. So it just saves a little bit of time, which is nice. So advantages, you've only got one constructor call in the whole of test assembly. So it makes refactoring really easy. It's a really nice way to remove data noise because all of the values you need to configure are explicitly set in your test. So like, with state, with minimum age and stuff like that. All the other values are hidden behind default values in your builder. The other really nice thing is that you can actually do more than just build an object. So if we look at the product builder, it's a little bit more complex because we've got a with campaign method that then stores in a private variable all the campaigns that you add. And then what we do is we actually build the campaign itself. Now, in this case, it's using a feature in Dossier that allows you to use a factory. In this case, it's the call constructor factory, which basically by convention passes through the values that you've set using the set method into the relevant constructor properties by matching the name, which is what happens when you actually delete that build object method altogether. And then after that, we're actually calling one of these domain methods, create campaign, on the built object and then returning that built object. So there's two really nice things that have happened here. Firstly, you can just do more than just what's possible with a constructor. So that makes these builders very powerful. The second thing is you've actually kind of started documenting some stuff about, in this case, the product object. We now know that a product object has a list of campaigns and you can create campaigns after you've built one. So you can start to kind of learn about the objects in your system from these builders, which is kind of interesting and puts an interesting slant on the whole tests as documentation kind of concept. So yeah, that's pretty much the other advantage, that they're expressive and that allows you to have documentation. I just see Shift Key in the chat there trolling me. Not too much magic going on, lol. Yeah, fair enough. So some of the disadvantages, there's some noise and verbosity. So like the new member builder, you know, it's just not quite as nice. There is definitely repetition across tests where you have objects that are created very similarly. So for instance, say that a minimum age of 18 is a standard thing in your system because you've got some sort of age restriction rule or something like that. So you might have a whole bunch of tests that have new member builder dot with minimum age or with age 18 or something like that. So you get that repetition there, which is kind of annoying. And the other thing, of course, is you've got extra code to write now. You've got this infrastructure code to create these builders. That's kind of where TestStack.Dossier comes in, because the way I see it, you write them once for each object. And if we can make them really terse and quick and easy to write, then that infrastructure code disadvantage kind of disappears a little bit. Now, there's one thing I will actually briefly show you, which is kind of a cool feature in Dossier that is very magic, Shift Key, just for you. And if we look here, it's this feature here. So one of the things we have is the ability to create a list of objects. So we can say product builder.create list of size 3. You say the first one with no campaigns, the next one with campaign, the next one with campaign. Now, these methods here are the methods on the builder. I can call probably with name as one of the other ones on the product builder, for instance. This is crazy magic. So we're actually using Castle Dynamic Proxy in the background to do this. But the really cool thing is, like, this is so readable and so terse. You know, you can do like the last and stuff like that as well, and all that kind of thing. It's very similar to the NBuilder syntax, but instead of having to do with and then like, you know, with name and that kind of thing, we can actually dispense with all the Lambda expressions unless you want to do a lazy value, and you can just call the methods directly. So I really love this syntax. I think it's so powerful and so readable, and it even works when you start getting a bit more complex, like in this example here. So that's a cool thing. So now's the fun bit. We've got the TestDataBuilder mother pattern. Now, I made that up the other day, that name at least. This is a pattern that I've been using for quite a few years now, and I haven't actually seen anyone publish anything on this technique before the post I had. That's not to say that myself and my colleagues created it or not, but certainly I haven't seen it used before. The basic idea here is that we can get rid of all of the disadvantages, or most of the disadvantages of the TestDataBuilder pattern by combining it with the ObjectMother pattern. So what this means is essentially our ObjectMother returns TestDataBuilder objects rather than built objects. And what this looks like is, if we look at demographics, our ObjectMother now has properties that return the builders. So that's kind of cool. So what does that look like in the tests? Here we go. So we've got ObjectMother.members. So it's just less noisy. It looks so much nicer. I think it's a lot clearer to read. You've got that wicked advantage where you get the IntelliSense off that, so you understand everything that you need to build in the system. And whenever you want to do customizations, you just dot off the end of it and you call your builder methods, as many of them as you want. And that's pretty cool, I think. So all of the advantages that we had from TestDataBuilder, we also get the consistency from ObjectMother, and we remove that repetition. So now what we can do is, you know, maybe we get to the point where we decide, okay, we've just done, you know, the same, you know, members dot with age 18 5 times or 3 times. Let's abstract that out into our ObjectMother, and now we can have ObjectMother.members.18-year-old, but then the tests that use that still would need to modify it further, but that's fine because they can dot off and say dot with email address, you know, shift key at crazycode.com or something like that. So the nice thing is that we get to have the consistency of the ObjectMother, the flexibility of the TestDataBuilder to change values per test, as well as the, what am I trying to say? I don't know what I'm trying to say. Anyway, I think I've made my point. So there's yet more infrastructure code, which is the main disadvantage here. Now, I think that it's acceptable personally, but you know, I suppose you need to you know, evaluate what you think. But like, to my mind, you know, that's pretty easy to write. You write it once, and you should only, they shouldn't turn into God objects anymore. These should just be like really common scenarios to get you started, and then all of the individual stuff in each test you just dot off the end with your builder methods. As a quick aside, this is useful for not just like your unit tests and that kind of thing. You can also use this to set up fixtures for things like database integration testing, automated UI testing, but also you can put it in a console application so that your devs and testers can seed your like database or whatever it is for things like manual testing and local debugging and that kind of thing. I've done this before. It's really nice. And because you're already maintaining that infrastructure code as part of running it with your tests, there isn't really any extra maintenance overhead for that. So just an interesting kind of thing to think about. All right, so I don't have too much time left, but I'm going to move on to creating values. Now, this is interesting in both our tests, but also our test data builders, because in the constructor of our builders, we need to set up common like initial data states and that kind of thing. So we're creating values there, but we're also creating values in some of our tests. So again, show me the code. This is where we pull out our calculator. A calculator basically keeps track of an integer value. And we've got the ability to add, subtract, multiply, divide, and clear the value. So pretty weird, contrived example. But what I've got is I've got an example of some tests that you might write, the ugly calculator tests. So you might say calculator.add1 should be 1, right? It kind of makes sense. Anonymous variables basically says the 1 here, it doesn't actually matter what it is. Let's assume for a moment we're not actually using 1 as a special value. We're just using 1 as a number. So having the value 1 kind of places false importance of it, like we talked about previously. Now, what you might do instead is you might abstract that out into a local variable, and you might call it, you know, a number, right? The anonymous variable pattern basically says anonymous number. So you just label the variable name like that, and that tells you the value doesn't matter. Who cares what the value is? We're just going to call it 1 in this case. I've got a slightly different pattern that I call anonymous values, where the value itself, because I don't like naming the variables like that. It's kind of, it's a little verbose. So instead, there's something in Dossier called anonymous value fixture. It's actually available in all the builders as well. So you can use these in your builder constructors. But you can say something like any.positive integer. There's 2 things that this has done. This makes this very readable about what our intent is. But the other thing is we kind of realize that actually what we're really testing is that when you add a positive integer from the initial state, you know, something happens. So we've actually changed the test name as well to take that into account. So now our test name is clearer, which is kind of cool. Now, in this case, any.positive integer actually gives you a random integer number. And I know a lot of you there are going to be like, ooh, that's bad. Hang on, doesn't that break repeatability? But there's two other patterns that I'm going to very quickly explain: equivalence classes and constrained nondeterminism. Equivalence classes basically says there's a class of values, in this case positive integers, for which the test is what we're trying to test. So it doesn't matter. Any of the values in that equivalence class, the test is actually the same test. And constrained nondeterminism says, yes, this test is non-deterministic because it's a random number, but you've constrained that using an equivalence class, so it's actually okay. Now, this is a really interesting pattern, not just for generating values, but to think about why you're writing your tests. But certainly it's very interesting in this perspective. So yes, I managed to get through. I think I'm only like a minute or two over. And that's it. That's me. Thank you.
Fantastic, Rob. Fantastic, mate. Very good. Very good. All right.
It's hard to fit into half an hour.
you gotta be on your toes, right?
Yeah, I was probably racing a little at the end. Sorry, guys.
That's okay.
Now, is there questions I need to?
There is a question. Let's see. So this question, Aaron, popped in earlier when we were talking about ObjectMother. Doesn't the ObjectMother pattern reduce the variety of test data you work with? And your answer is?
It's interesting. Just the variety. I'm not so sure about that. I mean, it kind of depends on the circumstance, really. So if you're doing things like, when you say variety, I mean, you're probably doing things like data-driven tests and that kind of thing, maybe to get a bit more variety of your data. In that case, you'd pass the values in. I mean, ObjectMother is more about the kind of common scenarios. It's like, I need a member that has, this is a minimum age or something like that. This could still be a value, or it could be a defined value like 18 because it means something in your domain. So I think it kind of depends. I'm not sure if that answers his question, but hopefully it does. There's one here that says, so always random unless you want to be specific to say do an assert on it. That's where the derived values pattern comes in. Now, I didn't describe that one, but I do have a blog post about it. So if you look on my blog for derived values, or probably on Mark Siemens' blog as well, then that kind of talks about it. But basically, you're asserting on something that's calculated from the values in your test.
Okay. David, I think we looked at PECs for testing ranges of values.
No, I haven't. But sounds interesting. Send me a tweet or something. I'd love to look at anything interesting that people think about in relation to this stuff.
PECs, by the way, is kind of subsumed now in what was called smart unit tests.
Okay.
I don't know if you've looked at them at all.
No, what are they?
So it's a 2015 feature, but it basically uses PECs and mols to exercise your code and generate test cases for you that you can then take and tweak and everything else. So
yeah, cool. No, I must admit, I haven't
looked
looked
at
any of that. Cool.
Would have been good if someone did a session on that, perhaps. Too subtle?
Are you putting your hand up, Richard?
No, we're done. And I can't talk enough anymore anyway. All right.
Put you to work.
Let's have a look at, let's have a look what else we got floating around. Looks like that's about it. There's some other chat comments. I don't know if you want to jump in on any of those in the chat room at all, Rob?
Yeah, I'll jump in after when we close off and see if there's anything interesting there.
No worries. Well, I'm going to do one thing and say, firstly, thank you, Rob, for jumping in and taking the last slot. It's always a hard one, so well done for that. We've got to do the applause. Chat room, You know what to do when you hear the noise. It's very cool.
For 20 seconds.
Yeah, they'll get there. Shows your pecs, seriously.
I'm expecting something big from Shift Key.
Don't expect too much. One thing that I do want to do, just in terms of wrap up, because this is the last session, I'll probably chop this off the back end of the session recording, but I'm just going to show this. There it is. All right, so I've just added something to the main site, being this here, help shape our future, which is basically feedback. So audience, I'd love you guys to jump in here and just give us some feedback about the conference, how you've enjoyed or disenjoyed, depending on how it went for you, and what you'd like to see in a next running. Nothing too fancy, it's only 7 questions. Ooh. Only 7 questions. You guys should be able to handle that. It's not too hard. So the link for that is on the home side of the web page. Anyway, you get the idea. It's been a long week. I'll also post it in a few other places, but that would be great. Clop. Really disappointed shift key. Oh dear. Apart from that, thank you, everyone. I hope you've really enjoyed the week. Thank you, Rob, again for your session. It's a great way to wrap it up. It was a cool session. Quick chat if there's any more questions. Thanks. Nothing else has come in, which is cool. And we are done for 2015. Woo! Woo!
Praise the Lord. All right. A bit awkward with just 2 people like whooping.
Yeah, it's like, yeah, what can you do?
Rock on.
You know, I've killed myself, so I've had to resort to the drugs.
Yeah.
We're done. All right, thanks everyone. Appreciate all that. And we are finished. We're out of here. Snagglepuss says exit stage left.